that might be work combo blockers or something. Sometimes when I'm working on something like that.
After that? Nope. It's there now, right?
Mm-hmm.
Right.
And it should work instantly.
Reach to turn the robot and uncover the echo test. Do we want to put the roll pitch yaw in here too?
No, because those get set. But they should be accurate to what's in the code.
There's nothing right now in there.
On that screen?
Roll pitch yaw. There's forward, right, and up, but I don't know if these are right.
What about?
There's nothing for roll pitch yaw.
Then that isn't getting set by the. Sure, I guess just copy the numbers and might as well. If you hold that though, it's going to change the shape of this. I would be fine
lopping it off.
chopping this off, but can you turn the robot around?
No, please.
You good?
Cut off on the carpet.
Y is left. Is that right? Nope. Is Y left? Right, rather?
Yes, and it should be negative equal left.
And negative 11 is where?
Back. And I put 21 degrees, I think, in the pitch.
And 180 in yaw.
Yeah. It was probably a combo of the 180 plus
Bad XYZ options.
Did I tell you 180 for the code?
Yeah. We need to change our exposure probably.
Well,
There, fine.
measure 21 from the. Is that what you just did? Measure from the ground.
Yes, sir.
Cool.
This is a bad angle for.
Cutting the whole shooter off, or the whole top of that off.
There you go. Is Meditech 2? Meditech 2 is the blue one, right? Oh no, Meditech 1 yellow, good. Meditech 2 not good. But we're saying the salsa already out there?
Yeah, it's right here.
The battery?
Yeah.
We were home so little that my very fast charging phone only got to 80%.
Whenever you guys leave.
Hey Kevin, could you get the vacuum, please?
Yes.
Right there.
Oh, 20 is the wrong value. Oh wait, something just changed.
On this side. Done. God, I feel amazing right now.
Where's the...
I don't know what the actual one is.
I'm gonna set pitch to 0 too. Let's just.
Oh! It's not, we have pitch and yaw backwards. It's just angled up. If you look at the hose saw, it's like angled to the right.
I'm making them all zero.
Okay.
The line line is still angled
Yeah.
in the. Yep. Line line's not upside down, is it? Can you encode the angles for? Side plate.
You take,
We'll take.
I'll do it. Maybe a please would be nice. Jeez.
Yeah, dude, we're all working, dude.
How do I die? Might be worth it though.
So metal.
You died, we're doing a robot.
Now they're okay.
You there?
Did you deploy?
Yeah.
So the configuring code must be different than. I'm going to just change them in.
Other than our robot getting backwards, it's better. It's like rotate 180 degrees.
When I set pitch to 21 just now,
And it went like this.
it didn't. My visualization still shows.
I don't know how often it's setting it. You know?
A little hack. Force the line line to.
Okay. But not repeat code.
Should lose.
Yep, and then it flashed back. Same result. Basically, the correct-ish pose, but the robot's rotated 180 degrees.
So it looks like the angle position values we put into the GUI are getting ignored in place of the values from code. Can you put pitch to 21?
What? Sure. Now it's Well, this visualization goes up.
Well, that one has graphics. That one should. And that one faces that horizontal. That's what I got the 21 number from. I just saw it.
Should we put it slightly more centered? So the back of it looks better? Or say it's way off? Is it possible we have robot in the wrong like X and Y positive negative backwards?
I don't know why the pitch is apart.
I have 21 pitch though. Oh, you're saying a preview? Look at that.
I see the 21 pitch right now.
Oh, now we're back to the far side. Oh yeah, see the 21 pitch on yellow.
And it's gonna snap back.
Oh! That's different.
Yeah. What's going on? It's gotta be wrong.
I mean, is it green or red? No.
No, the visualization is all messed up with line line. Where the line line's pointing. So I kind of want you to get rid of the code that changes the.
What do you see the visualization on this?
It's upside down. Or it's fine.
Okay. What do you want me to change?
Well, okay, let's check the code first.
We're setting internal IMU.
We're giving it a rotation 3D,
Correct.
which is that, does it take in, does rotation 3D take in radians or radians? That's
So, it's, how do you do this in correct units?
Can you just do degrees of 21 dot in radians? And then do a yaw of 180 as well. You maybe have to import degrees and radians.
Cans are getting tossed.
Because it won't auto-import those.
Corey, is this your waffle?
Nope. Oh.
That's Reese's with. Why, are you clearing up a little? Or?
A little bit. I also just wanted the stool for
Got it.
Sorry, Corey, I didn't walk.
Corey. I will walk. Is this your favorite?
Nope.
There you go. Another trick.
high over 180 or yep.
Oh, you know what it's gotta be? It's gotta
What was that?
Man,
Do you wanna try the home command?
sure.
Like that's a 60-second try. Doesn't work.
Do you know how to do that? We're just gonna go back and build its own.
It probably is going to ask for. Yeah, I'm looking at it.
We haven't slept in days, sitting reminiscing on the ways we stay high in the clouds, promising that we won't come down. It feels so good, it feels so true. The only substance I need is you. It feels so nice, it feels so true.
Hanging in?
But we know there's something deep we can't forget. It feels so good, it feels so true. The only
Please let me know next time you want to play code. So you're gonna be down. Sorry to.
Forward to some. What?
Change the turret hood angle? Or see how it shoots the hood as it is?
Oh yes.
One of the two?
Yes. Hood. Hood testing. I gotta put on safety glasses.
How's it going, Reese? Just working on the longer flap thingy? You're fine. I kind of heard but didn't really register before. You said, let me know if you move the arm or something like that?
You want to deploy code because they need to reset the arm.
Oh, yeah, okay, yeah.
You just need to remember to zero it when or not trying to move it.
Perfect.
Is all in?
All the way in.
Okay, let's try two. Can you face the turret forward?
You want to do it this way? Like forward
Like
or
straight forward? Thanks.
New.
better?
Let's just double it. Can we do like a whole hopper? And do it from that same spot again, maybe?
I want to test the hopper feed thing. David sent me a video of their shooter, and it looks basically the same thing. They're doing the same thing with their intake. I think the actual strategy is to figure out how fast your feeder is pulling balls out of the hopper, and basically just slowly tilt the intake up.
I think it's a jostle, and if you drive your seeds near the end, I think they maybe press another button to complete the finish.
Sort of like.
I think we're good there. Let's do that. Let's do this. That's a lot of balls.
Video.
Yeah.
All right.
3, 2, 1,
Spinning up.
If the intake comes down on a fuel, then we're closed. Or disabled. Because it fault skips.
I went flying upwards.
What? I think some, it was this. Some polycarbonate shavings. Do we need a shorter angle?
Where you start on the line. The line's good, right? We'll figure that out. Drive in here. Shooting on it.
Yep.
Is there something else you want to test? I need to figure out exactly where it's at.
We shot the entire hopper in 20 seconds.
50 balls, 20 seconds. Or 20, yeah, 25 and 20 seconds. 25 seconds. On average?
Yeah. That's if we're at 50 and we were a little less than 50.
Sure. I think that could also be very optimized, like much more optimized.
We didn't hear it over the heater.
No, true.
I don't know what that is. It was here on the table.
It is from finance.
I remember here having that was the one from Thailand. Yeah. It's on the other side. It's unopened.
What about sodium? It's literally just like a lot.
You have to turn on it.
Oh, bumpers overlap their robot string.
So you can't
Not
see.
contact the bump. We don't need to see. You just put it in a location, turn it off, turn it back on. The pose, you just have an assumed starting pose. Your first trajectory assumes your pose. Right?
Sure, we can try. If it takes off somewhere that, then we disable.
Yeah. Do you want a path layer? Because I don't
Maybe Pathfinder has a new field.
Oh. No, probably not.
New field available. That's
Wow. What's that?
line to shoot. So where's my zero? Gyro zero. Oh, this is bad.
What? What?
Because it'll change depending on. Okay, that's. I don't know how to do this. specify starting pose, but will it flip the starting pose?
Just put the starting
If
pose.
it's on red.
Yeah, I think so. There's a arrow thing in the top right. That will show you on red. Oh, that just shows you red side. Never mind. Okay. What commands do you want to call on it?
Let's start in the center and do a manual drive backwards robot relative. And then it'll pick up angle tags and the angle of the car. That problem will be solved.
Drive backwards, but I can make
Is
it.
it drive forwards? Is it
Yes. It's from where
It's a little bit of a dumb step to have to take, but I think it's gonna save our butts.
it's for 2 seconds. It's 1 meter a second.
Just one.
There's a named command called drive backwards that will start you out. Lowercase t, capital B.
Well, that's fine.
tell me.
So
You're on
I am doing any more to the auto, just
Let's just do drive first. After that, we'll figure it out.
I don't know how you're gonna get this on.
I'm gonna do what?
How you're gonna deploy this auto?
Is it like live reload or not? Drive. No closing speed. Backwards. This way is I think that's fine. But when you're saying we're gonna shoot there, okay, yeah, let's try that. That's the sort of path. I think that's good. We don't have any other grounds to it. Other than like if we were trying to kill that to get there. Okay,
It's
is that what this is? We just want to go back. No, not quite, but
Yeah.
legally more, actually, usually.
Yeah.
We talked about this the other night. It's like
You don't have a floor.
a minimum of $1 million per row of our data. We have like petabytes of data.
Try to go fetch and cash.
Oh, that's fun.
That's a lot of money.
Yeah. Infinite money glitch. For the US government.
That's a US help.
Yeah.
Jordan, would it be reasonable to say if we can clear off all three of these tables, all four tables here, we consolidate it all down to that one table with excess parts?
That would be huge.
Okay.
Please
Easy
don't
goal.
just- Please don't just throw everything over this.
I'm doing my best to organize
Yeah,
it
yeah.
as best I can.
But yes, just a consolidated mess would be nice too.
Should it not work?
No.
Well, I can transfer the files to that one.
And code to that one.
Alright. Nice.
Can I try some get stuff in?
Yeah. At least like right now I'm at least trying to group like all tools go like the fast here. Something like that.
Can Pathfinder, can you push it to the robot?
Oh yeah, you can add CC files to the robot if you want to try a file transfer.
Oh,
It just puts things in the code directory, right? Yeah.
You must have left this and checked it out.
How did you get in?
He let me in.
Oh.
Did it not ring?
No, they disconnected the doorbell.
What? Oh.
Ryan, I thought you said did it rain? So you can tell how I function.
Jordan, unless you guys do that, we can keep it disconnected until after we run the show. Put a sticky note out, so it's called this, not hard. Always coming.
Yeah. Did somebody make a note and tape it on the doorbell that says it's not? How do I get those files off?
Get problems. So, with transferring code around to the robot, corporate machines don't allow USB source devices to attach,
But they allow.
but they allow arbitrary.
server.
Yeah.
That's it.
That's how the cloud works.
So I need to be able to get out.
Oh, no. Yeah, Corey, I think you guys need somebody who can like speak to some of this stuff.
Back to shoot and send it over. No, you're in deploy. Top button. They rebrate. There you go. Right there. Are there GitHub issues right now?
Yeah. Alright, I have 5 things changed.
He has 2 origin commits push. And I fetched the remote for it. And it's a bunch of NRC.
Yeah, so you're gonna get full origin Ri3D. What if there's like a merge command for that? So
You wanna get this commit in your,
Yeah, there's one hole.
okay, so I would dash everything first.
Run auto now.
I mean, it can always run auto.
You like big wobble. That's what we call it. Running auto in 3, 2, 1.
It's supposed to do that.
We want to drive forwards. My bad.
So good? I didn't like editing JSON files. Sorry about the little auto. So who doesn't like editing JSON files through an auto?
You wanna hold on to
Wait,
these?
you
Any buffer amounts we use, same one for each asset.
Are you saying do we want to keep them?
Yeah, do you want to
Throw them in one of our boxes. Yeah. registry. Auto stabling. Here it's going.
Was that first drive supposed to be that slow? It sounded
It's 1 meter a second.
okay.
I guess make it 2.
No, I just wanted to
I think it's trying to do a 180.
It's always with like the deploy actually.
yeah, that actually like
distance. Are you on red lines?
I'm on red lines.
Yep. Give up.
Um,
Okay, so that was finished. No more needed.
what?
No, I'm saying that's perfect for all clean.
Okay. Turret or shooter.
Shooter speed.
Based on distance.
We'll look up. More helpful?
Shooter's not good.
Yeah, we can get distances though because we're not so you're correct. That is the first one.
Pretty close. Yep. This is good. So this is too much, right?
Yep. Well, we're just gonna see if we can have the possibility of making a shot.
You can lose it. Is the arm all the way in? Yeah. Okay. What you didn't take out? And then we got shooter. Ready? It's 71. I think we can make it if it's slow.
Is there a way to ask AI to use Elastic to grab a shooter value from Elastic when we run that?
Oh yeah, that's fine.
That way we can change this on the fly. I would.
So just like periodic.
Yeah. I mean, like, it's the kind of thing that someone would already depend on someone having made, but it's not.
Shooter speed and it's does that work or should I just do this?
someone be feeding balls in?
Kevin, put a few balls in. Or I can feed balls.
You're just gonna shoot one. Well, you're gonna.
Yeah.
You're just gonna put balls in the hopper as we are testing. Okay.
Just one at a time.
Yep.
Swing up.
There's no such thing as a yams cleanse.
Okay.
Unless you can find it in your APIs.
Okay. We're hungry home. Enable.
So if you think about I'm going to stop and start that. Stop and start.
And even in the unconfigured mode, we're not getting any kind of actual speed reference.
Now we're good. Get a battery.
Morning, Ryan.
Oh, the intake. Do we know what the pose of that center of the
The
hub
hopper doesn't
Yeah,
actually.
we work 7 more hours in restaurants.
What? What's that? Why?
Yeah.
That's alright.
They called it course up there, okay? Yeah, it's 7 more hours.
They should have used the AnyMark launcher in a box. More proud sponsor. AnyMark. Your one-stop shop.
They did, but then they decided to go more complicated.
The robot pod is also not as illegal as illegal as our robot is.
Oh, how are they
So see how our hopper extends out our front, and then our shooter extends out our back.
Did you fix the hopper window?
Yes, yes, it's much better now. See those little flaps that are the intake as it comes down, it pushes on the sides of the hopper. It's like, stay out there.
Yeah.
concept. I think it wouldn't be that hard. I think with some time, it won't be that hard to get it figured out.
Figure it out. Let's do it.
I mean, I know how we would do it, but we decided to prioritize other stuff.
Yeah, let's do it.
I mean, I can still do it right now.
Nope, don't do it.
See? That's why we didn't do it.
You can do it if you shut this.
I'm not gonna be here.
Oh my goodness.
Yeah, in reality, it'll be me and Jordan and Corey fixing it.
Because I made some design mistake.
Like the day before any like tournament competition.
Sometimes we're gonna have practice, so like,
I have Discord open. I don't have Discord.
it's gonna be difficult to score.
Show this out.
Huh?
This game is difficult to score already.
If you don't have electronics.
Yes, we have vacuum somewhere.
Give me the vacuum, I'll vacuum make the field look nice.
This guy.
You want to program instead, Reese?
What?
You want to program instead?
I wish I could.
What was 3D? Red,
Yeah, it said this guy because he acts like I don't know where it is.
X11.90.
My guess is probably somewhere in the back. I'll go up here in just a second. I'm just trying to recharge.
Take a nap.
Resting my eyes, as my mom would say.
Oh, this is meters, right?
I was like, I don't know what back in the day.
You assume so.
From
Okay.
slide?
4.031.
Okay. And don't care about good job.
Wait, we're going out?
We're getting our distance to
Cool. Do you need a shallower angle?
yeah. Well,
Sure.
I'm not 100% sure. I'm pretty sure this is the closest we can get.
And we want to get closer.
When you close, you can see break.
I'm
We're
But
gonna.
there's also like passing goes out the window.
I mean, I'd rather score balls. I mean, we'd say to gain the ability of passing, you need an adjustable hood.
You know, also just is now the time to switch the batteries? No, he's about to. We're also just running with like set values. We're not doing speed control at all. We're just YOLO 0.57 is how far from here. Cool. The speed control is going to take too long. We have 1 hour. What do we want to do in an hour that we have left? Auto we failed. Can't get past plan. You don't think we're going to in an hour?
We can try.
Yeah, I definitely try. That's the biggest game we could make is a turret. But you gotta, yeah, it's gonna be difficult. There's a lot of things to it.
I mean, if we do a turret and they're always short or far, do you care about that?
You do turret and they're always online. That's, I think, better.
Okay. Then let's pause this. What?
Well, yeah, like I want to get this distance and then the far distance, and we can linear interpolate between
Yeah.
and just call it good.
Okay, we know where we are on the pose.
You want a shallower angle before you do that.
Nope.
Shallow or steep?
Shoot higher.
That's it. They want to get close to it.
take the car side.
I'm not doing no one there.
No, let's not do my own part. But if you could take that side of the field,
Yeah.
I'll take this side of the field.
There's extension cords there.
Oh, yeah, I feel like you can put it there. That'd be something.
Yeah, you could like subtract them and then do the norm, or there you go.
Care about some number
No, sir.
that's like
Expert for yourself.
What would you call a type of climber that inserted itself into the side of the pipe and then rotated itself up?
Pin State climber?
Huh?
The Pin State climber?
Pin stake climber?
Pin State?
and have more than
Is that what that is?
Yeah, they did it. They did
That's what Madison
Oh, really?
was trying to do too.
I call it a
good translation. Oh,
The translation is.
rotary climber.
Rotary climber.
It goes in.
Yeah, like literally just like goes into the pole, clamps
No,
and then rotates.
that's not what Penn State did. Penn State used the.
No, I think they did insert and they used the upright as a reactionary force.
Okay.
I could be completely, you may be completely right on that, I could be completely wrong.
This one spins, but
No, it's level one.
I mean, there's like six
well, they all
Hey,
spin.
buttons to do it.
they don't spin in real life.
Yeah.
But I figured that.
IRL.
I'm all
So
ready for.
I have to admit, I thought what we were gonna see is the rescape, these things, getting reused for the climb.
I really thought that's like what we could do.
No, like put two of those up and you have angled bars already, and then something like on top.
It's a day.
Reuse something?
Huh?
Reuse something?
You fool.
Fuel? No, new fuel.
Yeah.
Well, you don't have enough old fuel.
Well, you know what the problem with this fuel though is, Ari, is that if you end up having way too much, that's gonna be way too heavy to use as packing material.
I think we'll be fine.
And now you also have two fuels to talk about.
No, we have so much fuel in our warehouse right now because we have artifacts from FTC, we have
Right.
fuel, and we have fuel. It's all fuel.
But how many powers?
None.
What?
Well, maybe like two.
That's
I think we have two.
2.6 meters.
You got a lot of those FTC rings. I know that. Those orange ones.
We're actually out.
Really?
Yeah.
You guys finally got rid of
Besides all the old ones in the Mackie room.
How about the whipple FTC velocity vortex?
We still have a lot of
108 inches.
Did Nathan ever show you what we do with this down?
102.
those. If you have a picture though, I'll look at it.
Yeah, I have a picture.
I'll
I sort of did it, and by the end of it, I was like, man, this is a lot. Alright. It's what
And then like it
Reese,
opened
can
up.
you put a ball in?
what?
Go put a ball in. No, don't make Corey do this.
Yeah. I use the shock rack.
Yeah.
It doesn't pick up anything.
Oh yeah. Yeah, I already have all this breakfast sandwiches if you want them.
Hello?
Oh, I said there are breakfast sandwiches.
Oh, okay. I will take it.
around the camera.
Great job, guys.
Do you have a value you want to
Great.
try? What's he say?
Yeah.
It's gonna be more, but.
Give me like 5.
It's good. So, can you measure center of robot to center of hub? So I got the tape measure.
You guys, just with an hour remaining stuff, just to think about some general plans and what you can cover over
176 to frame, so 180, 189. Or no, sorry, 190.
Got mine right there. Let me think where frequency.
like, yeah, I'm gonna build that. And it can do like a non-linear, like, you can have multiple entries in one. If there's any kind of like, I don't know, maybe we can cherry pick.
Yeah, I'm just gonna pull like the code that we need.
Yeah.
So give you.
Yeah, it's in its own command, so when she got approved,
I really want to get the turret spinning.
first of all, look how beautiful. Yeah, I don't know how you use it, but the code you want is going to be
Robots 6.876. It's always rotations of the output.
Yeah, if you just copy like the
The end of the mechanism, yes, the turret.
At least in games, that's what we're. No, but it's not.
and those are in like rotations per second, I
This is what
think.
we found out. Yams isn't 4, but no, I think it's the really? 42 per.
Google flat buffer.
Yeah, for entry. Like, hey man, that's a good
Well,
one.
actually, I mean, now would you do this?
Alright, so this is.
You're a little bigger.
Take one.
This is right?
Yeah.
Yeah, and I think we'll turn off the generally like that. But
That's funny. It's literally it's almost the exact same interface as like my old interpolation code.
Well, that's good. It seems like these are off the house.
Yeah, but it's
I don't know. Sometimes the episodes are
I just really remember the sound of that key.
outside my
well,
5 amp stator.
Oh, did we have the long range?
oh,
Stator is gonna spike. Yeah.
Yeah, I have some other.
exposure value has to be like not
Under,
in order to pick up the ads.
Operator control.
This might be how it's supposed to be.
Drivetrain is on the road, so I'm like, or the localization of the
Yes. Swerve.
all the stuff like
yeah.
anything stored is
Public. Double. Jet.
Level 11, make a wish.
What?
11, make a wish. Yeah, that's what
I
I was
kind of imagine what I would wish on. We didn't swear, I don't see why we're getting.
None of these values
What?
Like some of them are
Yeah, but we don't anything that is short.
So, what do you do is, what do you
We stopped working. We cruising the robot as is.
More like ones for them.
I got to reach today. Last night was not
We're gonna coffee. Hopefully by then the coffee thing by Jimmy is on the lyric for the show. There you go.
That's why.
It's very healthy.
not partner.
Yeah.
But I think it's
Got some new federated.
the light said it
The nose is a subsystem.
It's an instance of nostril. Oh no, it has two instances of nostril.
Yeah.
It has an eject method.
Yeah, okay. All humans have.
the last few years.
Yeah.
The April tax have been more low or like the speaker came at it and it was screen.
Very fun.
Sorry about the noise, chat. I'll set up the camera.
Where are we at with respect to
Try to remember how to.
What?
where are we at with respect to
It should be like.
Just want to make sure that we're in the block.
Actually, I've got to
what I was gonna do?
Also,
Tell me when to stop. Tell me when to stop.
this should use. Right.
So you're covering, you're almost about to cover some of the lights. Keep going down. Keep going. It's not there. With your other hand
I know.
on the
like it'll register a new symbol. I think micro is something. Yeah. Oh yeah, maybe something is good. Oh yeah. You working? You roll what?
Let's start planning out so we don't have to stop for discussion before. The order of topics.
Yeah, well that would be it.
We took the robot out.
Drivetrain intake, move to the progression of the ball. Drivetrain intake, hopper, kicker, shooter.
Do you want to talk about the drivetrain and then drive over the ball? And then send it and land on some fuel. And then
Do you want to do that first in case you break anything though?
We should do some bump testing by ourselves.
No, like if you do it during the show and you break something, do you want to leave the bump for
Yeah, we'll do the
last?
bump last. We'll do the bump more full of stuff. Full of balls. That's what everyone wants to see.
That's a good idea to do that last.
yeah.
Also, wait, you're talking about driving the bump, right? We can try and deploy the hopper with the intake too. Like the very last thing, right? You just be like, this designed to be like this with social tubing. We didn't want to do it in case we broke something. YOLO.
Just maybe put that under like your own like water.
I think that's going to be first. Because it
We
works
want to
like
prove that no
it's
it's working.
going higher.
I just wanna see if, yeah, cause it's not,
We have a good feeling that it is. Like, very good feeling.
it's not like us getting lost.
Start shooting stuff.
Yeah, that one says it's running.
Did you unload it?
I unplugged the, that one.
It's
This one is,
power that.
like, there's no lights, so it's not activated.
Factory saying that there's
Well, no.
Yeah, hold on. You know,
Wait, don't plug it back in. It's in here.
we've had the Novas not have any lights and still run them. That does not necessarily mean it's dead. Tell me, do you still want it enabling for you?
Yes.
Okay.
Turn my voltage to the
Not.
No, like, if you unplug it, it should have a constant polarity between two phases as well, because it'll try to commutate to the next.
Make sure it's getting 12 volts first.
Yep.
Oh, it's on.
This is what we saw before. We popped one out of breaker, put the breaker back in, and it started working.
Well, it's not working right now. It doesn't have a complete. If we disable it, we can start robot code. I bet it works.
it stops flashing when it gets configured sometimes, and then when you enable, it starts doing the height.
Oh, so you're playing with the mediator.
So it's still loading robot code. Let me know what happens.
Flashing
It's
neutral.
definitely distance in. Loading power.
You just enable for it.
Nope, not yet. It's loading robot code.
And sorry, you saw that was the factory reset.
Oh, sorry, I'm deploying code. So.
Oh, you deployed. So our test is done. So it's fine. Enable it? So it thinks we're max distance. Talking about this on the same page with the command. It takes the first value and it doesn't. We're really into that.
I had this just a double like half second here.
So for zoning, so shoot at distance is accepts a double distance and a double supplier.
Okay. This is just how it goes player.
You don't want to get this over here, right?
That's the issue. So that has to go.
It's like a zombie. Way over sucks. But it'll save me like $40, so I was like, you can pay $200 for on my layover, you can pay $200 an hour.
How long's the layover? That's pretty good.
An hour. Save me $200.
I was wondering why you were taking a layover.
Yeah. Is it 150 or 350?
This is
Yeah, for Fort Lauderdale.
That's the
My way here was direct, but my way back I'll stop in Orlando and then lay over to Fort Lauderdale.
I don't know that for sure, but it's easier to play. Or at least walking back, you can put two
So you're going to Fort Lauderdale and going to I know a lot of people
Sorry, guys.
What other Apple
Just so
After we run this test, it needs to be
Alright.
check out how the
Show ready.
are to that. The vacuum,
Yeah.
vacuum out stuff, or the compressor blower.
would be flanking.
Right. Yep.
I think it would be so bad to get an Navex out of here.
Is the Navex, do you want,
It's doing the cycling.
do you want,
I'm leaving this Navex over here off board just in case you need a hot shot.
so, just a suggestion, last year you got it, you should have got
What?
you should have got the charter. But,
I mean, but I think
We just have the Netflix.
It's already like so I'd rather just vacuum it first, see what happens.
It was a game.
Because we'll plan on doing full demo first, and then we'll check our code. That's what I'm saying, so when I switch over to extra, so that gives you about, that's what, 15 minutes or so. That's fine.
I would be fine unscrewing it and leaving it unscrewed for us to pop out. Screw doesn't come out and roll.
I mean, you said it.
You said nobody didn't care. You said it.
You know what that's called? Finesse.
They're still working, is that what
hot swapping that? With robot on?
Why not? It's just like digital bullets.
Alright. Go for it.
It's just electro. That's how wired works, right?
Jordan, hear that?
What?
11:30.
Please, can you check the dip switches and see if 1 and 2 are on the other one? Yes.
You show the robot off?
No, you don't know now, that's.
That's fine. Yeah. You have to have a good night's sleep.
Yes, on.
Both on?
Both on. Jimmy. You want to do the old NavX? You want to do this different NavX or same NavX?
Same.
Is the radio still plugged in?
Yeah.
Okay,
Oh. Yeah, I grabbed that. Finding more.
Just take one out, I'll take the and then I'll keep that.
That's not informal code. They're bullets. I mean, it's more expensive. But they're just gonna feed it.
What's the jumper gun? Would that make it like more reliable, robust? Yeah, where's your answer?
Robust versus plenty.
If I could make a NavX chip that would like work really well but fail right before like, I don't know, a competition in week 4.
I do not know why I cannot play it.
Yes, there's nothing better than exploiting teams' need for competitiveness to gain financial gain.
Hey, man, coopetition.
Sabotage.
Yeah. That is, I want my trademark on coopetition.
Yeah.
Yeah. Right? You go in and help a team, you're like, you guys, you swerve, and you get them through a couple of Saturnian things, and then you're just like, alright guys, see you later. Now our drivetrain doesn't work. And you have a single turn.
Would die.
It's gotta be this.
Remember when we had that
What?
20 more minutes, then you can have.
You want to put this on?
Yeah. Okay, where did that driver go?
We check out on this
And the outside drive.
Alright, I'm getting ready to give up on Blur.
Can't play.
And
Did
What's up?
Can we reboot the Rio, please?
it's I just saw it.
Power cycle?
No.
Oh, not crashing.
yeah, the
Yeah,
big
it's crashing.
We've seen the Rio. Yeah.
I cannot deploy.
That's a weird.
Are dying.
Oh.
It's a weird.
Power cycle?
Okay.
I
Yeah.
oh, you pulled the cold board, ultra board.
Okay.
Yes, please talk.
Because it's
Is the Alex about to go back on?
Yeah, put it back on. Let me put this away.
I mean, it's a good thing to try anyway.
Well, that's it. You know, let me start showing.
Yeah, they can't like, if it was trying to like Oh, holy shit.
That's one.
Yeah.
And like you go in a box just now. So.
Hey, a 6-7. Yay.
You have one.
I'm just gonna, Corey, are you saying Nick Slurp? To start trying to turn?
I don't. Oh, you know, the sexual piece.
So we do point at.
Drivetrain eight. Okay.
So it's handed off control to a native node and that's executing.
Okay, so I'm trying to deploy it.
Yeah, not yet. Give it a minute.
Or communication with the real itself. So yeah, all this stuff is really slick until time.
Shoulder. Y. Mid, right bumper. Sure. I like it. It's okay.
Figure out how to get it.
The clearance back here is in place here.
Okay, you're using the yet another library.
Yeah.
Yeah, that's there. Correct.
The thing is that we spent, I'm not kidding, 12 hours proofing all this. Yet another line, yet another line, yet another line, and now we're hitting all the issues. We're hitting
Yeah, well, yeah.
the smart move.
And then start thinking about
Right bumper. Anything else you
So
want
that's
to
out of your direct control. Yeah, look at monkey patch, right?
18 minutes?
Anyone?
I'm trying to do it.
I have the list of names up here. You can like tally next one if you like, if you want to get general consensus.
Oh yeah.
What y'all choose one?
What about Cat Dad?
Dad, but it's cardboard aided design.
Maybe we call it
Okay. Right bumper. Yeah, you did get started with the supplier. Just the robot. Right there. It's
No, we need it on this book.
call it Papa. You know, for like Papa John's, so we use pizza boxes, but we can use Domino's boxes.
This is just blocking from the camera. I can't even see on camera.
No, you're just blind. You can totally see the robot on camera.
cat.
Alright.
It's pizza thing.
Reese
Maybe get the cat.
Oh, it's pizza.
Black Papa?
Maybe call it thin slice.
Yeah, thick slice.
Deep crust. Deep crust. Yeah, deep crust, deep dish.
I mean this would be serious, like, what about junk drawer? You can't close your junk drawer because there's like a pair of scissors sticking up this wrong.
Junk drawers are everything.
I do like that.
But only in the most affection.
Yeah.
Maybe we call it criminal. Because it's illegal in a lot of different ways.
It's not a lot. It's like, take 2-1.
Maybe we call it the felon.
No.
That's gonna be great on YouTube SEO.
Gonna really get that 10 out of 10.
Any other suggestions?
Smooth criminal.
If it were thin slice would be amazing.
What?
If it were thin slice.
I call it thin slice because it's like, you know, it goes under the trench, you know what I'm saying?
Does it?
It does.
That's it.
That was
That's a
rude.
great question.
Well, we'll see that in the demo.
Yeah, there we go.
Do you guys want to write down like what you all want to cover, just in case you miss anything in the tired and fatigue that you guys have?
Yeah.
So Samantha can write down for you if you guys want to figure out what order you want stuff to go in.
I want to follow the progression of the ball. So like drivetrain, intake, hopper, kicker, shooter, launcher, and then climbing at the end.
Kicker?
Kicker.
Hopper, kicker, launcher.
Yeah.
Can I offer one associate? You're not going to be talking about going over the bump till the end, right?
Yeah.
Did you want to say drive till the end then, so you can more demo how that works?
Yeah.
Yeah.
I feel like you're writing like some weird corporate acronym right now.
You're stiffing him.
Yeah, it's like comes to don't pronounce that.
Yeah, there's no good way to.
Anyway, yeah.
It's called shorthand, but yes.
That's why we're leaving drive to the end.
Icked.
Ickle.
50 minutes.
This is why it's pickle.
Oh, you know, it's even worse if I write shooter.
That's why it's a launcher.
No, I'm calling it a shooter.
Score. No.
This is why it's a launcher.
Ultimate shooter. Yeah, I don't think you will say. Yeah.
And for some reason, schools don't like mine.
When do you want to put code?
You feel the.
Where do you want to put code in this?
I'm correct now.
Yeah, code's a really strategy.
Reese, move your butt.
I could put a crash out right here.
Crash out's good.
Right here.
Crash
okay,
out
so
right
let's
after
just
Hopper
go.
makes
That's a
the
good
post.
robot name.
Crash out?
Yeah.
Maybe the intake's not that.
So you guys have fixed the model?
When the intake's down.
Oh, yeah, I see.
Okay.
That look good?
Let's log these.
Where's the crash out?
Station before we start. Where does this go?
Aim to pose when
Oh,
we're done.
Oh,
Crash out.
You're ready to sleep on the drive home, aren't you?
I always do that when I spell crash. I say CH like every time. It's
So
not
you
a
get so
tired
excited to put the SH at the end, you just put CH at the front.
Yeah.
Improvements.
improvements before code?
Basically, when you release.
I don't know where we're at code is.
Back to
Code
default.
fit.
Yeah, I think actually improvements should go after the shooter.
What's it called?
'Cause-
Oh yeah, you want to something like this.
Okay.
well, I guess it'd be mechanical improvements, then code improvements.
Yeah, like, well, is there any way that we can log the target values?
Supposed to show it. Yep.
I did it.
I spent so much time ahead of time getting all this to work.
I have to
It's quite
rewrite those.
frustrating that it is not right now.
Was I laughing earlier?
The wood?
Gargler?
So why
They
components
were
of
gargling
rotation
on
to be
top of
zero?
That's
I mentioned that.
It's not, it's a
It might have been doing.
AMAC.
Anyways,
Right?
I wrote it down.
It's AMAC code, it's not.
When the writing gets smaller, it's now
It's like a.
six. Six.
Did anyone confirm what the starting locations were?
I did not.
For what?
Like auto?
No.
Thought it was
Yes,
just the
like,
line.
is that
Line across the entire thing.
So you can start under the trench? Well, not directly under it, but like lined up with it?
Yeah,
That'll make beelining to the middle.
That will be the strat.
No
You
shooting.
can shoot from there. You shoot your 8 right there.
No, I think you gun it for the middle, come back and shoot as many as you
Well,
can.
you have something good to target your 8 outside.
Yeah, true, very true, very true.
Then auto starts bang middle.
Driver controls, target hook codes. That's
Still like gas can.
Why gas can?
This is full of fuel.
The first thing that came to mind. And then I think gas tank. I make a tank.
Let's call it Eco Boost.
Go loose.
It does look like a sand crawler.
Okay, so we're
Mini
calling
fridge?
rotation to just mini fridge is cute. Our
Okay,
pose
we're-
is
Okay.
now you go back to the
I mean, I guess it's a hybrid since it is 150.
The what? The Chevy Spark?
this is static, so it doesn't matter if it's possibly called.
what is it? I don't know what the power is.
Goes to the target.
Target pose is a what?
Goes to, it's literally the hub pose. It's returning the hub pose that I want.
So I wonder if it's mad that rotation 2D is 0.
Oh, call on that. Use rotation to the .k.
0.
I mean, I think it's like zeros.
It doesn't matter because this is the thing to point at.
Yeah,
I
this is
know, but-
causing an issue on the.
Zero. Like that.
It's not a function of the. It's like a symbol value.
Is it K capital Z?
Yes.
Oh my.
Is there a scientific word for being sleep deprived?
Probably.
We have like 3 minutes and I should run off full system stuff again. Maybe even just now.
Just see what it does.
Yeah, insomnia.
Insomnia is good.
Insomnia
seen
is
that
the,
as a
is the word for sleep deprivation.
So that's a bonus.
No, it's
Doesn't-
That's the
same
actual
thing.
condition, but
Yeah.
Yeah, but
Look out, please,
I can't see him, so we're pointing the wrong way.
We think we're pointing. Oh,
Are those yours?
we think we're pointing.
But it wants to point our robot 180. So what do we do? We're in red.
Or there's the poses.
I think at the end of every section we talk about what we would do differently to maybe get a little bit more power out of
Somewhere auto
the system that we're talking about.
yeah. If you end up doing that, you just skip over that one.
Yeah.
Okay. Rewriting.
You just get like red.
What? I thought there was like a rotation offset.
Yeah, it will say, oh, sorry. This doesn't matter. It's when it triggers. Do you have that in there?
Did you end up using any marker last year?
Yeah. The line that disconnected. This one's for Andy.
What?
This one's for Andy. Yeah.
Because if there's anything wrong with like the other stuff, we don't need it.
Somebody's along like those.
It's not happening.
This was the front of the don't worry.
I literally pulled up really hard. But I think there's no way you're pulling it off.
Oh. No, don't worry about it.
Where's
Oh yeah.
Slack the stage to go.
4 minutes.
How we doing, guys? Hey guys, let's go ahead and call it on-off code iteration. Let's do a full system check.
You want to run that while we look into it?
All the way up. Just keep going until the hard stops. Why is it not going up? It should be going up here.
Oh boy. Do we lose values? You still seeing updated values?
Move the arm up some. Careful though. Nope.
Okay. You ever start? It's down to 0. This was the same issue that you saw right here.
happening.
It's not the same machines. That we weren't getting good values at all. And it was not.
It's not worth trying to figure out right now.
No. We literally like we weren't seeing any updated encoder values. So. Ahí Dios mío.
2 minutes, chefs. 2 minutes.
Ay Dios mío.
Okay. 0, enable, look out. Spin up.
Michael's done.
Right over here.
Tell you what I'll do. I'm gonna move it. Over in this one.
I think definitely starting this whole thing that before we get into the whole intro that this spot is not. You go in a couple of ways, and that teams should take our findings and apply them in their own way, and not take everything we did one for one.
Don't start with it. Yeah. You mentioned it about the
We,
The robot's holistically valid. You just have a couple of mess ups.
yeah, I agree with that.
You're
It's
the
not-
googly eyes.
I know.
I'll short me some on the side of the polygon later. Otherwise.
Why did I choose to live by?
Pretty much. Yeah, yeah. We're 1 minute away, so I'd start preparing.
Time's up. Alright, chat, we'll be starting in just a couple of minutes, alright? Just gotta get a couple things set up for the show.
Do you need a table over here, Tyler?
No, I just need my cart for that.
Yeah, that's what I mean.
Okay.
Why is the toast on the plywood?
No, you're not going to be in the show.
Make tag 2 or make tag 1?
2.
That's 1.
No,
Make tag 2 is whack.
no, but we're using the Megatag 1 angle values to inform Megatag 2. It's new.
Do you want to have the robot there at all during the show?
Wherever you want.
Want a couple minutes later? We'll go in.
Okay, if you want to get the able text to show that off during it, or if you can far away, let me know, so I can plan the recording to the camera. Otherwise,
Just go to 0. We lost values. Stop. Disable. 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 Disable.
Disable.
It works until it doesn't work.
Are we gonna drive it?
Yeah.
Well then, that's a problem.
Why?
It's just gonna be clicking. That's fine.
What do you mean? Reset. We lost encoder values on the motor. When we reset the Robo Rio, it comes back.
That is.
It was.
What?
That was after a reset.
Let's do another reset.
Reboot it.
Okay, and let's enable.
Do you want to reboot it?
Yeah.
Like reboot, or restart code?
Restart code. And then let's do a system check real quick one more time. We lost values on the encoder and it just kept slowly closing into itself.
Okay.
You guys just check some stuff only to get stuff up ranked. Please don't get anything else.
No, yeah, we're not.
What are you saying?
Yeah, I just saw a bunch of.
You said we're not adding anything else.
No, we're
Just
not.
checks.
That Nova is off now.
The arm one? Move the arm. Move the intake. Yeah, we're getting values.
Okay.
Okay.
Let's enable, do a quick
Enable.
system check.
Drive. Intake out. Shooter speed up. Down. Up again.
Come here. Come here.
Okay. Arm intake in and hopper in. This is like starting configuration. Oh, is that going on now?
No, just handed it to me.
Wait.
I mean, it's.
If it fits, it sits. No,
Yeah.
that was on
Inside front corner.
He switched
They
it
care
up.
about having
Oh, that
it's show our
was.
sponsors.
Iris.
Yeah.
It's part of our bumpers.
That's right.
Yeah.
That's what all the cool teams said in last year.
mounting hardware.
No. Can't be higher than this.
Can you make sure that fuel goes under?
Yeah, that's a problem. The fuel doesn't go under.
Well,
Like, can you not mount it like that? Essentially.
yep. Right here.
We'll take it off when we go to drive another
Yeah.
range.
Right here it is. Perfect.
Hey. Okay. Tyler, I'm gonna switch power sources on this.
Okay. So,
Yeah.
chat, the camera's going to go out for just a minute.
Thank you.
Just a couple things real quick, guys. No matter how far you get stuff, just remember that you guys did awesome. And this is something, think about how many teams that you spoke to last year that took inspiration from what you guys did. No matter where you got in progress or anything like that, you guys are making a huge difference on that. So let's take a moment, pose yourself, let's figure out, pathway, what you guys need to say and move forward. But you guys should be proud of the progress you made.
Yeah, big thing we should definitely talk about is our improvements. So we're gonna be
100%. So process-wise, we'll just let you guys go through everything that you need. So let's break down, whatever you want to talk about, demo stuff like that. Then we'll take Q&A after.
all done.
Yeah, but I want to let you guys just go through everything that you need to do for stuff first.
Who's driving? Doing system check. What? Okay.
Alright.
I'll need when they go to drive. I'll need hands with balls.
Yep.
I'll need hands with fuel.
Yep. This is why you call them fuel.
Remember for stream, there's a lower third here and then a little box up here.
Yep.
It won't be on the
Myself
recording,
doing that
Yeah.
day
at
0,
least for stream.
and so I started calling it fuel, and I felt dumb while I was doing it. But
Now
I
you
just
don't
call
feel
it
dumb?
fuel.
Yeah. So, drivetrain.
We don't talk.
What?
Drivetrain last.
Oh, okay.
After every section, we're going to talk about how we can improve the system.
We're good on
And what are we demoing? We're demoing things.
We'll demo the system along the way.
And then they just run the robot at the end.
Yeah.
Are you on mic?
Code/crash out. Oh no.
Let's get a. There's going to be a lot of talk.
Hey. Hey, one.
Yeah. Yes, please, sir.
All right, check 1 2, check 1 2. 1 1 2, check 1 2. All right, chat, we'll be starting in just a moment. Check 1 2, check 1. You gonna start out, Reese? Okay. All right. Once everybody's ready, we'll get in position. Samantha will give a nod.
Nice. Cool off, you know?
Where's the Gatorade?
Chat, just a reminder before we start, we're going to do more of an overview first and then demos, and then we'll take questions after. So you can ask questions. We'll try to grab as many as we can, but we're not going to get to those until a little bit later, just so we can go through and showcase the robot more.
All right. Ready to go? Let's do it. All right. Hi, everyone. Reese here with Cranberry Alarm Ri3D, and I'm here with
Jordan. And Corey.
And today we're going to be going over our day 3.5 or Tuesday overview of our robot and where we ended up after our 3-day challenge, and talk about all of our systems, how we integrated intake, hopper, kicker, and shooter into our robot to be able to score fuel into the hub. And along with some future considerations that we would make to basically play the game better than what we are doing currently now. So to go and kick it off, we'll go ahead and kind of go through the progression that the ball would kind of go through the whole robot. So to start, we'll go ahead and talk about our extendable hopper and intake, as these two are kind of closely related in how they're going to kind of operate. To start, as a quick note, we are not currently actively extending out our hopper. This was purposely done because we knew in our time constraint we wanted this to be a focus that we did at the end. However, we kind of ran out of time and wasn't able to make this a big focus. But we know that there are many solutions that you can employ to make the hopper stay stowed within your starting configuration, and 2, actively deployed. So our main solution to this would basically be using the intake to hold the hopper in starting configuration, and then as the intake deploys out, the hopper would then release and deploy out via some springs or some surgical tubing. And this is just using some shoulder bolts here on some guide rails, heavily inspired off of 254's 2017 robot. For our intake, we're powering this intake pivot. This is a normal pivoting intake right here. We're powering it all off of a Max Planetary on a 25-to-1 gearbox, and then an 18-tooth pulley powering a 60-tooth pulley. And that's all driven off of one side here, and the other side is being pivoted via this peanut bar right here, extended across it to help maintain that the two sides are synced. We're driving the belt coaxially via this set of pulleys right here, and that goes down to an Andy Mark Sport Gearbox 4-to-1. And from there, we can pivot this however we want, and it's very light since there's no motor attached to it, and we can continue to do whatever we want with it, and we'll still be able to drive the intake in whatever position it is in. We pivot the intake down, and from this position, we'll have, you've got a ball nearby. Thank you. Corey, do you want to go ahead and talk a little bit more about this?
Sure, yeah, I can talk a little bit more about the intake design we ended up with. We tested a few different types of wheels and roller bars. We tested AndyMark compliant stars, ThriftyBot 4-inch compliant wheels, and this AndyMark silicone tube roller kit. And the one that we ended up going with on this robot, as you can see, is a silicone roller kit with ThriftyBot dead axle on either side to drive it. But a little bit more about the design. You can see on the side profile that we have this backer bar here. We found that when intaking the fuel, it's really important to have something other than bumper material in contact with the fuel to get a consistent and reliable intake. But the compression that we're running here, the center of this axle is 5.5 inches off the ground and is around 5 inches to the backer bar. So around 1 inch of compression with the backer bar and a 1/2 inch compression with the ground. if you have too much compression with the ground, we found that the fuel kind of sit outside the intake and just roll. If you had a more compliant intake, then maybe the intake would bounce out of the way and pull the fuel in, but we're going with a rigid driven pivot, so that wasn't an option for us. But yeah, I think that's a good overview of the intake. Do we want to run the intake? I'm going to go and have Reese bring the intake back in, or I can do it. So right now, as Reese mentioned, this roller bar is running on a 4-to-1 with a sport gearbox. We think that we would like a lower gear ratio for the roller bar to be spinning faster, but we didn't end up having time to change it or do anything different. As you can see, it does pretty well at touch it, own it, grab the fuel, pull it up into the hopper. We found that sometimes if your hopper is a little bit too compliant on the edge, your intake roller can take the fuel, push it outside of your hopper through this gap. With a little bit more time, maybe some more structure or rigidity to the hopper can fix that. But that's how our intake's looking so far. We're happy with it. We think that there's some changes to make that you guys could do to improve it, but the most important parts are compression with the ground and the backer bar, and having something back there like a backer bar or other material to get a consistent intake.
Yeah, so our plan right now is that basically we'd be driving around the match with our hopper out the whole match. So once basically it deploys, it'll stay out the whole match. I think there is definitely some mechanical magic you could do to basically get everything to fit up. Basically with the intake, when it comes up, it actually pulls the hopper back with you. And you can see we're using these little fins right here, and this basically helps kind of keep the hopper stable and tied to the intake per se, without actually being attached to it. And this kind of really helps with the floppiness that we see from the intake and keeping everything rigid. So you can see here, the hopper becomes very, very floppy without anything there. So we'll maintain this position somewhere kind of elevated right about there whenever we're driving around in the match, and that's kind of a good position to hold all the fuel inside the hopper and allow us to drive around. Then when we begin indexing, our plan was to agitate like this, and then maybe finish with a big swing like that to basically get the remaining balls into the hopper. But while we got a bunch of balls in the hopper, let's go ahead and just do a live test of the hopper, and then we'll go ahead and talk about what's going on there. I'll go ahead and adjust the shooter. So we missed every ball because we were aiming wrong, because I don't know how to orient the shooter correctly. But as you guys can see there, we do a good job of funneling all those balls out. That was probably 30 some odd balls, and that we managed to cycle through in 6 seconds there. So we were cycling right around 5 balls per second through the hopper, which I think is a great benchmark. Ideally, we would have been able to do 10 fuel per second, but we're really happy with what we're seeing with the 5 fuel per second. So to get into the specifics of it, the main concept is we're using the polycarbonate sidewalls to retain all the fuel, and then we're using a hopper floor that's powered using the Andy Mark silicone tubing, powered by the Ri3D bot idle tube rollers. As the fuel makes its way through the hopper, it comes to 2 sets of Ri3D bot 2-inch vectored intake wheels, and from there it biases the fuel towards the center. And from here, the 2 compliant wheels here in the center force the fuel into the kicker assembly. And so this was something we played around a lot with. We had originally these 2-inch stealth wheels here all throughout the bottom. We had too much grip and it would squeeze the game piece, and this ultimately just didn't work out well. We switched to the Thrifty Bot vectored intake wheels on both sides, and this was really the sauce that we needed to be able to get the balls moving the way we wanted to. We still occasionally have a jam here and there, but as you guys can see, moving those balls through was fairly successful for us. So let's go ahead and load it up one more time and do another quick test while I go ahead and talk about it. Go ahead.
Yeah, one thing to note about the fuel, we haven't talked about it yet in this video, but have mentioned it several times in our previous videos. The fuel don't compress much, so your mechanisms are going to have to be the compliant part. And Reese was mentioning how we had stealth wheels all along the bottom, but the fuel was kind of just getting jammed and getting stuck. It's because the fuel don't have as much compliance as previous game pieces, and so you have to interact with them a little bit differently as they move throughout your robot. We're going to do one more full hopper test here, and then I kind of want to get some close-ups of individual fuel in the hopper kind of moving through, and talk a little bit more about some details we found. Spinning up the shooter now. You can see that occasionally we have a little bit of a dead period where fuel aren't moving through the hopper, but it works itself out. I'd like to point out these zip ties that we've added to a couple of the rollers. Without those agitator pieces or the zip ties, the fuel would sit and spin and just treadmill on 2 of the rollers, and so we would end our outfeed into the shooter with like 4 or 5 fuels still in the hopper. But all it took was a little bit of agitation, and that fixed itself. Let me get rid of this fuel. I guess we would have to fix that for a final robot. But I'd like to show individual fuel moving through the hopper because it's really impressive what these 2-inch vectored intake wheels are able to do with the fuel if you've got the compression and the setup right. So let's go ahead and see. And then Reese, I'd like you to, when the hopper is stopped, just set a fuel in the corner of the vectored intake wheels. This is really impressive. And after we did that test with vectored intake wheels on the bottom and top, we were happy with that and pretty confident that this would be able to avoid jams for the most part and feed the hopper feed the kicker at a good rate.
Yeah, so that about does it for the hopper. I guess to end off with a few improvements that we would want to do for this mechanism. The big thing would be dialing in the whole hopper siding, making so that it's maybe a little bit more rigid in a few more places, making sure that it's actually actuatable and does everything that we want from it. So we can go ahead and move on from there, and we can go ahead and talk about our next step in the path, which is going to be our kicker. This is a fairly simple mechanism per se. But this is basically a set of wheels that its job is to move the ball from the hopper into the shooter. And so we're running a set of 2 1/4 Andy Mark compliant wheels on the bottom there to basically move the balls, to move the fuel through the kicker. And this is all being done with about 5 inches, or with about 1 inch to about 3/4 inch of compression. Our center to center distance was about that much, but then we ended up separating the Thrifty Bot wheels just a little bit to reduce compression to help the balls go through a little bit smoother, and we found out that worked out really well for us. And so that was all just a little bit of fine tuning to figure out what worked well, but ultimately we're happy with what we're seeing from the kicker and its ability to move the balls up through. And we're all pounding this from 1 Neo off a 4-to-1, and yeah. And for improvements for this mechanism, really don't have a lot of improvements for this mechanism. We're really happy with what we're seeing from it. Ultimately, we want this to be going as fast as possible. We're pounding, like I said, we're pounding off a 4-to-1, and it's going from a 40 to a 32 tooth gear train with a finishing ratio of 3.2 to 1. And it's important that this gets a bunch of speed on the ball so that the as the ball arrives to the shooter, it already has a bunch of velocity. Therefore, we can maintain consistent shooting from ball to ball. So ultimately, we're really happy with what we're seeing there, and we can go ahead and start talking about the shooter. Do you want to cover this?
Sure. So, our first take at the shooter, our first prototype, was to take the Andy-Mark launcher in a box, the Andy-Mark for deploying that. Just set at a fixed angle and try out some shots. The Andy-Mark shooter in the box is everything, or launcher in a box is everything from this plane up. So the side plates, the churros, and these 4-inch stealth wheels come with the launcher in a box. You'll notice that the side of the stealth wheels have the Andy-Mark flywheel add-on, and that just gives it a little bit more inertia. The process of fine-tuning this shooter and getting a good compression was pretty simple. They have these gridded side hole patterns so that you can adjust the placement of these churros, which move the perf board in the back, which can set your compression. I think right now we're at like 0.65 inches of compression on the fuel, and we found that works great. Too little compression and some shots would fly far and some shots would be duds. We didn't try more compression than 0.65. It was kind of a case of it looked really good, so we just went with it. But to talk about the lower half of the shooter, everything from this bracket down is the Robotics 6 7/8 turret kit from Andy-Mark as well. And these two kits mesh together really well. Only a couple modifications had to be made between the spacing of how the two mechanisms meet. So apart from like mounting brackets and a few spacers, the entire turret assembly is commercial off the shelf from Andy-Mark, which we're really proud to have done and tried out. Unfortunately, we don't have control of the turret. It's not something that we got around to in our 72 hours. So we're running with a fixed angle. But we didn't find any issue with shooting fuel from 90 degrees or 45 degrees. There's no alignment inconsistencies as we're firing. Reese, do you have any other comments about the shooter? Good. If not, we can sort of run single ball tests and maybe try and drive our drivetrain. We're running the shooter at a fixed speed right now. Well, not even speed. It's really just a % set point. So we're a little bit limited in our control, but we are powering it off of two Neo 1.1s, which are 1-to-1 with the 4-inch stealth wheels. And those are controlled by Thrifty Novas that you see on either side of the turret. But let's go ahead and turn it on. We're gonna have to drive the robot around a little bit to dial in our shot. But we found that this shooter setup is pretty consistent. We feel like a lot of the inconsistent shots that you're going to see are probably due to differences in fuel. It looks like we're in an okay spot right now. Looks like our shooter stopped for a second there, so we've got a fuel stuck in there. If you feed a second fuel through, can we just show that unlodges the stuck fuel? So there's no real issue. There is a dead spot between the shooter wheels and the kicker where a fuel could get stuck, but since you're launching multiple game pieces, we found it to not really be an issue. The first one is just going to come out with a lower velocity because it's getting hit by the second one.
to a flurry.
Yeah, sure. Now we're going to test out a large number of fuel to see how multiple fuel back-to-back affects the range, or if it does at all. We didn't experiment with adding more moment of inertia to the shooter wheels, but that would potentially help in a test like this to become even more accurate. You can see some shots are long, some shots are short. With velocity control on the flywheels, I'll reiterate again, this is just percentage set point. With velocity control on the flywheels, you might be able to dial that in even more and get even more consistent results. But for right now, we're really happy with it. It's been performing really well.
One more cycle.
All right, we're gonna do one more cycle. One challenge with a turret type design is dealing with routing power and CAN and any other signals to the turret hood. Especially if you're going to try for 360 degrees of you can see some shots are short. That might just benefit from a little bit more velocity. But as I was saying, one of the challenges with a turret is always how do you get power and signals to the turret hood. And with our turret hood being limited to 180 degrees of travel, it becomes a little bit easier. We've just got an energy chain here sort of strapped to the hopper with enough slack that when it's rotated all the way to the left, the energy chain is taut, and then when we rotate all the way to the right, the energy chain kind of flexes the other way and bends out of the way. So with a 360 degree turret, this would take a little bit more consideration for us to figure out how. There are plenty of examples of previous robots that have 360 degree shooters without slip rings that are solving this issue with the energy chain, but in the 3 days we didn't really get around to experimenting and testing that.
Yeah, and I think like Corey mentioned, our current shooter is powered base %V. So as our battery power goes a little bit lower, we're going to be having a bit different shooting performance. So one really big key to unlocking the most performance and consistency out of this shooter is going to be more inertia and powering this off of speed control, and then a really good PID to basically maintain that speed. As you can see, when we were feeding one ball at a time, we were getting pretty consistent results. The goal is to be able to see those consistent results as we shoot a flurry of balls. But ultimately, we're really happy with the consistency. And what this has shown us is that we're basically in the corner of the alliance zone right now. You can see, if we're looking around us, we have basically the full alliance zone here. And this basically tells us that you can really shoot from anywhere in the alliance zone really effectively. And that comes really important into strategy and how it's going to play out. You can see as these balls are all around here, we basically are feeding all these balls around to us. Likely your partners can also be feeding you balls, and so being able to shoot from anywhere in the alliance zone is going to be really key. One really important factor to that is going to be also to have an adjustable hood. Right now our hood is fixed right now. We actually don't know what the angle is quite 100%. We were at 45 degrees, and then we drilled a new hole and adjusted a little bit lower. So we don't actually know what the new hole is, but we know it's a little bit lower than 45. So yeah. We can go ahead and do a couple of cycles right now. It's just showing the whole robot doing a bunch of intaking and then some shooting, and just kind of showing off the whole system working as a whole right now.
You want to mention the shooters stick out while we're driving around?
Yeah, so you guys can see here, right now our shooter sticks out about an inch outside of our frame perimeter. And so this would actually make our robot illegal, as we are sticking outside our front end with our hopper. Packaging is a big challenge this year. So give yourself more room than you think you need. and just try and give space for everything that you're going to need, and don't design a turret that goes outside of your frame perimeter. And there's definitely a lot of things that we could do to solve this, like adding a 2x1 along the front rail of our chassis so that we can extend our frame perimeter by 1 inch, and that would help keep us inside the frame perimeter. But that's just one of our constraints of being 3 days, that hopefully this concept gets across and then you can learn from what we've done here. So this is where having a faster intake would definitely be beneficial here. As we drive into the flurry of balls, we're getting some jams. And as you can see with the flexible hopper there, we're getting some bounce out. If we were able to make that more rigid there, we would be able to hold on to those balls a little bit longer. So as you can see with the %V, as we've gotten a little lower on battery, our shot performance has gone down pretty drastically. That's just where being speed control is going to be really, really important. So this hopper and intake system is designed around filling up the hopper fully. There's another viable strategy which you could do, which would basically shoot the balls directly into the back hopper and go for a smaller hopper and go for a more pass-through style. Very nice. We're going to do one more cycle. And we're also having a little bit of NavX issues right now with our gyro. So Corey's having a bit of difficulty driving the robot consistently. And we also have a bit of a lower speed on this, so you can imagine with a bit of a increased reliability, we have a bit better driving performance. So we had a really good flurry there at the end there. So that'll about do it for our cycles. So maybe this will be a good chance to go over some questions, or do you want to keep going?
Yeah, why don't we go over a few questions? I don't know if you guys want to do a battery swap too and stuff while we're going over some.
Let's do that.
So yeah, we'll take a quick break to do that. So a lot of questions on the hopper, so let's hop in. If you do have questions, chat, if you're watching live, do put them in. We're going to get to as many as we can, but we also are going to try to cut off in about probably 15 minutes. Anyways, what is the max holding capacity of the hopper extended?
So it's a bit of a gray area on that, because in terms of the intake being able to bring those balls in, we actually can't do that right now because the balls continue to follow out of our hopper through the front. But if we were to ignore that issue, we are able to store 50 balls inside of this hopper.
And we did do a test earlier with that, so you can check out one of the many videos that have been posted on Fun in regards to that. A few other questions. One coming in from ER Munich asking, can the hopper handle a big hit while the intake is up because of the floppiness?
Yeah, so that's actually the goal of this. The floppiness is to actually be able to take a hit. I mean, this should be able to take a pretty good hit. You see from me kicking, it should be able to take a good hit from the front too. Everything is kind of designed around being really flexible. There's no metal being run besides these 1x1 angles here on the front side. So it's all designed around being super flexible. This polycarbonate roller has nothing on the inside, so that can flex a bunch. We knew that with our hopper being out the whole match, it was going to need to be flexible. It was going to need to take a hit. And so that was a really big design consideration for us. But it's a double-edged sword, right? Because now, because of that, we deal with this floppiness. And if we're going outside of our frame perimeter on the sides, that would make our robot, in another case, illegal. So that's where it was really important that we had these little arms right here, which help constrain. And so it's pretty close on if we're going outside of our frame perimeter, but I think with the arms, any movement outside of our frame perimeter on the sides would be pretty inconsequential.
What is the center, Benaya Hills asks, what is the center distance between the vectored wheels?
I would actually have to check the CAD on that one. Do you know that?
Yeah, I think if I remember off the top of my head, it's like 2.63 or something. It's whatever.
No, 2.63 from the
Oh.
two vectored no. It's probably like.
I got it.
Yeah.
Between the vectored rollers, I think we're sitting at like 3/8 or
They're saying from the
a
bottom one.
quarter inch of compression. So they're going to be like 5.75 or 5.625. We're going to have Reese measure right now. Let's see if I'm right.
7 3/8 minus 2 inches. It's 5 3/8.
All right, so we're running, 5/8 of compression.
And the goal with these is actually not to compress the ball a whole lot. You actually kind of just want to like kiss the fuel as you're kind of moving it through the system, and that's what works really well for the vectored intake wheels. It's also important to note that at the same time it's actually touching 3 faces at the same time. If we go ahead and remove some of these right here, I can illustrate that. Right now, when we're touching here, it touches the 2 intake wheels first. And there's about a 1/16 of an inch gap between the fuel and this back polycarbonate. And as we begin spinning, it touches on this back face and can then translate. And so there's really not a lot of force that's being put on between the ball and the vectored intake wheels, because this polycarbonate wall right here is limiting it from going back further.
Let's talk about the shooter a little bit. How are you adjusting range motor speed? And then another question that was asked by 300 Degree, what is the benefit of adding launcher hood control, and if so, how?
So we are controlling our distance right now via flywheel speed. You want it? Take it.
I can talk about this a little bit. So there's 2 different ways to really control how far and what kind of arc you're getting on the balls. As mentioned, one, there's the shooter speed itself, the flywheel speed, and then also kind of the hood exit angle. Right now, like we talked about before, we don't have an adjustment for the exit angle hood, so that's stationary. So we were just getting to, 3 days is kind of a lot of work. And we didn't quite get to it, but we were doing some linear interpolation. So basically what that is you go to a known location shooting on the field, we measure the distance between the center of our robot and the center of the hub, and then we just guess and check some fine-tuning values of the shooter speed. And you do that from a couple different spots on the field, key locations, things like that. And then with the code, you can basically say, these are our known shooting locations and motor powers. If you're halfway between those 2 values, use a motor speed that's halfway between those. So we've posted all of our code. I think that's not quite up on our GitHub, but it will be shortly after this.
Let's take one more question before we go and weigh the robot and do a few other things as well too. So in regards to your flywheel, there's a question that came in. Would you recommend a really heavy flywheel or the one that you guys went with? How did you go through the process of selecting this flywheel, and would you maybe select a different one?
Yeah, so as I mentioned previously, the process for selecting this flywheel it's what came in the box, and it worked well enough for Ri3D purposes that we said, cool, it's good, let's go and run with it. It really depends on your feeder mechanism and how the fuel are entering your shooter. If your shooter is doing the bulk of the work to get the fuel up to speed, then you're going to need a huge flywheel. But since we have the hopper into the feeder into the shooter wheels, the fuel are moving by the time that they get there at a pretty consistent velocity, and it's on the flywheels on the shooter to do the last little bit of adjustment. So I think that this system could probably benefit from a little bit more flywheel and moment of inertia, but I don't think we would add much more.
All right, let's keep moving on. We'll grab some more questions in a little bit. We have some more demonstrations to do. We're going to weigh the robot, show some driving demos, talk a little bit more about code. What do you guys want to start with?
I think we should weigh the robot.
Yeah, take the battery out.
All right. Gonna turn it off. Maybe I'm not the person to be taking out the battery. I only have one hand. So right now the bumpers are mounted from the bottom of the robot, so we're not going to be able to take those off easily. But the max robot weight this year is 115, and your bumpers are allowed to be 15 pounds, if I remember correctly. It might be 20. These are definitely on the lighter side of bumpers. I'm gonna guess these bumpers are 10 pounds. But all in, bumper plus robot were 108.6. So I'm gonna guess the robot is like 98 pounds. This lines up with our first wave of the robot. We were sitting at, what, 94, 95, and we've only added a little bit of weight since then, like the peanut bar and a few wheel changes. So I'd say we're sitting at 98 pounds pretty confidently. But let's go ahead and go back to the field. Do we want to talk a little bit about our strategy, or do we want to keep fielding questions?
You can talk about strategy and stuff, otherwise some drive demos would be great.
Yeah. So while we drive demo, do you want to talk about why we...
Yeah, so the archetype that this robot is really came down to flexibility. There's going to be a lot of ways that this game can play out. So there's two big considerations that we wanted to have with this robot. We wanted to have the ability to pass from the neutral zone or the opponent alliance zone into our alliance zone, and we wanted to be able to shoot from wherever the robot is positioned. Excuse me. Secondly, we also know that winning auto is one of the biggest keys to winning matches in this game. If you can win auto, you immediately go into an inactive period, and that's actually a good thing because that allows you to collect balls, get more balls into your alliance zone for then scoring. And so after we've thought about it more, this robot could be maybe even more successful with actually a smaller hopper. Because if you utilize passing via your alliance partners passing to you, or you go in the inactive periods, you go to the alliance zone, throw tons of balls into your alliance zone, and then now, let's say you only have a capacity for 20 balls in your hopper. As soon as a ball goes into your hopper, it's immediately shot out via your turret and shooter and shot into the goal. And so now, instead of holding 50 balls and then going to go shoot 50 fuel, you're actually just constantly shooting fuel. So in this case, if we were to look over at this flurry of balls that are over here, the robot would basically just be able to drive through this, and all of these balls would go straight through the hopper and up and into the hub as we're moving along. So there's definitely a lot of really key ways to play this game. It's going to come down to just how well that you can package your robot and play the game. It's going to come down to your alliance partners, how well you play with them. But ultimately, we feel really confident right now that passing is going to be really, really big in this game. Considering, like, if for the same reason, if you're in the alliance zone constantly scoring, you can be in the neutral zone and you could choose a set point to be able to shoot to. Like, if I was in the neutral zone, I could say I want all the balls that I'm shooting to arrive right here. And so therefore, I can just be driving around and all the balls are aligning the alliance zone, and then from there I drive into my alliance zone and I have all these fuel here ready for me to start scoring with. And so ultimately, there's a lot of really good ways to play this game, but ultimately I think the passing is going to be a really big strategy to play this game effectively. And on top of this, our robot has no climber as of now, but we still believe this would be still really effective for us to have, and can only add to the effectiveness of the robot. So it's actually probably one of our best intakes.
Can you move that bar?
Yep. We're going to do a passing demonstration. This is new to me. So you can imagine if the robot's moving around a ton. It's important to turn on the shooter when passing. So you guys can see, you can basically, as long as you're not shooting across the net that's going to be here blocking, you can either choose a set point over to the left side of the alliance zone or right side of the alliance zone to be able to pass effectively. And then once you've passed, now you can then, during your inactive period, all these balls would be moving through the shooter at once while the turret is automatically tracking the goal. So we'll just do a couple more cycles, just kind of showing off the robot and how it's performing. We're really happy with what we're seeing with the 3-day challenge. The name of this game is going to be testing and iterating and really squeezing out the most performance that you can with this robot, with your robot, to be able to do the things you want to do.
Hey Reese, last night when we did the Monday recap, I think there was a little bit of not as much confidence in where you are now. What was the big change between then and where you guys are now?
Just sticking with the process. That's all it is. You know, we're not going to have all the answers, and you won't either. And you can see here our hopper is still dealing with some bugs right there. Our flanges that hold the hopper in place got a little messed up. Really, the process of this game is going to be testing and iterating and just dialing in your concept as much as you can. There's a lot of unknown variables to this game, so you just got to try it, fail, and try again.
A really good question I want to ask that just came in. Did you find backspin on the ball consequential or beneficial? And any thoughts on additional wheels to minimize spin?
Yes, that's a great question that I've been thinking about a lot. So when shooting into the back of the hub, naturally, and then we saw this with 2022 also, you're going to be shooting into the rear side of the hub. And so having backspin is similar like in basketball. You hit the backboard, it shoots down into the basketball goal. So for that reason, we think it's very advantageous to have backspin. However, you know, you can also add, like for example, we're using a 4-inch wheel on as our main flywheel. You could add a 2-inch wheel on the top side where the perf board is right now to add compression. And that will reduce backspin, getting you more shot time. And I know a lot of teams did that in 2022 to increase a lot of shot consistency. So there's a lot of things you can play with. All right, so let's go ahead and fill up our intake one more time, and we'll go ahead and do some intake bump testing. Got to restart code? Okay. We are having some issues right now with our code where we do have to restart our reboot our restart our code every once in a while to re-zero our intake shooter. So you can see this Andy Mark stuff here is really, really good. That actually picks up a lot of carpet hairs and maybe other people's hair. This is really, really good stuff from Andy Mark. We've been nothing but pleased with this stuff. So highly recommend this to any teams. From what we've seen, it has some of the best material to material grip on the fuel. So overall, we're really happy with it. Okay, and that looks good. So we're going to go ahead and fill up our hopper, and we're going to do a bump test now. Yes, under the trench.
Yeah, let's do trench.
Let's go ahead and fill up our hopper, and let's drive under the trench. Like I mentioned before, we're having a little bit of gyro issues, which is affecting our ability to drive effectively. So it's important to note that when teams fill up their hopper, there's likely going to be some teams that have some overflow. All right, we're just going to go and drive through the trench now. And, we actually have to rip off our sponsor panel. It's bye sponsors. Yeah, so fuel tolerance is going to be a big thing. I don't know what the correct tolerance is going to be on the trench, but I know the tolerances normally are plus or minus half an inch. I imagine the trench will probably be a little bit tighter tolerance this year, but you can see we're going through it, no problem. So our current height right now is at 21.5 inches from the ground to the top. Our hopper is currently set at that, and also our shooter is set at that max height, and that basically defines kind of what our current overall height is going to be. So let's go ahead and overflow the hopper right now, and let's see what that kind of looks like. From our preliminary testing, we saw that, you know, if you have some fuel that's going over the hopper, you might end up decapitating a mechanism or causing a bind. In this case, likely what's going to happen, we're probably just going to lift the trench up and begin driving with it. So let's go and see that. So actually some fuel's just kind of getting decapitated from the system. If I go ahead and hold that steady, when you guys want to, thank you. Don't go too crazy. So there we got a bind, another bind, push through. So there the hopper being flexible kind of just moved out of the way there. All right, and so coming back to see if we can get another bind here. We're currently stuck on one. Yeah, so you're gonna have to be careful when you're doing a max fill hopper going through the trench. And for most cases, I think it might be best to actually put some sort of covering over your entire hopper and then take it over to the bump. So let's go ahead and see. This will be our first time driving over the bump with a full hopper, so we're all gonna see it together. We know we can't go at a slow speed or the chassis will bottom out, so I say let's just send it.
Hold on,
Wait.
I can't. We lowered the speed.
Well, we can't. We lowered the speed. So we may actually we're going to re-upload code to be able to drive a little bit faster right now. Going over sideways, we struggle, diagonally, we struggle a little bit with our slow speed. We're going to go ahead. Yes, so we're currently using the, we're running on our entire drivetrain, the Ri3D inverted swerve drive with the TPU tread. And we'll go ahead and once we have a second, we'll show you what the underside of the robot looks like. We noticed this has amazing, amazing traction on the carpet, but not so great traction when it comes to the HDPE. A big benefit that you could get going to another wheel is potentially a Colson's, where they have really good grip on the plastic, or Black Nitrile would have really good grip. But it comes down to, are you willing to sacrifice some grip on the carpet to be able to get grip onto the bump? We're going to see if it really matters for us to have that grip here in a second. We'll drive backwards. Go ahead. Where our gyro's a little messed up, so he's doing his best. Looks like our drive speed is still a little slow. We're going to give it one more go. But definitely, all these fuel added into the robot definitely increases the weight of the robot. So it'll be interesting to see what our traction kind of looks like going over it. Do we have any questions while we wait?
What's the bumper clearance?
Bumper clearance is 1 inch. So 1 inch from the ground. And that's basically, our chassis is higher than that. But the bumper is going to be the lowest point on the robot the whole way. And we tested this, and with just the chassis, it worked out well. There we go. So I think we're moving faster now. So we'll go and try backwards first. Whichever way. Oh, wow, we didn't drop a single one. All right, let's go forward. Nice, backwards. So this is, like I said, we're having some gyro issues, so we're having some trouble driving straight as of now. But as you can see, let's go and do a couple more tests and see how it does. We got some air on that one. There we go. So it's really important to note that if your hopper is full and you can't go under the trench, you have to be going over the bump. And so therefore, you got to make sure that your robot's going to be tough to be able to handle these bounces. I already foresee a lot of robots are going to be going over these, and maybe the first bump, the robot's dead. And we're going to try not to hit Tyler right now. Still driving? Awesome. Awesome. So that looks pretty good. Let's see if we can get fully stuck. No, we're able to get off. Try and get the robot stuck if you can. Yes. Oh. It's important to note that with the lighter drivetrain where we had less traction on the HDPE, we actually were able to get stuck, but it doesn't seem like with the fuel added in there, we're able to get stuck. Let's go and empty out the fuel and see if we can still get stuck. Colin, come over on this side. And let's go and empty out the fuel. Okay. My team just likes watching me throw balls out of the hopper. All right, let's go and see if we can get the robot stuck now. Are you able to get off there? Awesome. So it looks like we're not able to get stuck, which is very nice. Awesome. Do you guys want to go and wrap up, and we can go ahead and talk about code and talk about what's next for this robot and everything that we want to improve and what our limiting factors is?
Yeah, so diving into the code, this year was a little bit new for us. We usually used a time-based robot, or the periodic one. This year we're using a lot of commands and command-based robot, and it's definitely a shift. We'd like to shout out the yet another software suite. Yeah, yet another software suite, and the yet another mechanism, yet another generic swerve library, yet another limelight. You might have heard those before, but they've been putting in some good work to help help make programming command-based robots a little bit easier. Jordan, do you want to talk a little bit more?
Sure, yeah. So we've programmed many swerve drives over the past, I don't know, what, 10 years. And like Corey mentioned, mostly in the iterative setup. So using kind of a framework library to do this, or a swerve drive generator, those kinds of things are kind of new to us. And so we had implemented some of the kind of like high level features that things like Yagzil and other libraries have, such as like cosine compensation, the skew, I forget what it's called, compensation. Yeah, so there's several different kind of high level features that a lot of these tools and libraries have that you might not have thought of before. And that might be, kind of harder to implement. So definitely, if you're new to swerve drives or mechanisms and things, we did a lot of the testing ahead of time in like simulation too. So it enables things like that as well. So yeah, definitely check it out.
And right into that, I'd like to start talking about improvements and things that we would like to change with this robot. One of the biggest ones, I think, would be more time with the robot for coding. We had a lot of ambition with the turret and swerve to be able to point towards the hub, adjust the turret, shoot on the fly, maybe even like pass to a fixed angle when you're in the center of the field. But we just didn't get around to getting those mechanisms to work and be under our control in the way we would need for that to happen. Reese, do you want to talk about some mechanical improvements?
Yeah, I think just to add a little bit more onto what Corey was saying about software, it's really going to be software that takes this robot from being an okay robot or a underperforming robot to be really a number 1 or number 2 seed at an event. Getting that automation going on this robot is really what's going to be able to take this robot to the next level. But in terms of mechanical fixes and improvements, I would love to make the robot legal in a lot of different ways. But this robot's meant to be a lesson to everyone watching and a lesson to us, and figuring out what works and what doesn't work. So as far as we see, there's a few improvements that we can make in terms of the hopper. Maybe the shooter we can leave extending out like that. But ultimately, we are pretty happy mechanically with what we're seeing. It would be amazing if we could eventually have an adjustable hood on this robot and really be able to have really precise shooting and shoot from wherever we want with really good precision. And climber, we really haven't talked a lot about climber, but that was something we also missed the mark on this year with just getting caught up with the hopper and everything else. But there's a couple of different areas on the robot that are open for us to be able to mount a climber. But ultimately, we just didn't have time to get it on. So we talked about this concept a lot, but never tested it. It was basically be angled telescoping tubes that would then extend up to the L1 rung and just climb like that. So there's definitely a lot of different ways that you can approach this game to get the L1 climb, but ultimately we didn't have the time to make this one fit for us. So that about does it. Do you want to have anything you want to add? Well, thank you to everyone so much for watching all of our videos and keeping up with us. It's certainly been a very fun Ri3D. Definitely been a lot of more unknowns this year than a lot of previous years, but we've been very happy with what we were able to produce and be able to provide the community with some insightful insight and showing a lot of the community what we did wrong, most of all, but also some of the things that we did get right. So we hope you guys all enjoyed watching us, and yeah.
Yeah, I'll just jump in real quick and say, for those who have had a chance to watch Cranberry Alarm, there are a lot of people that are kind of behind the scenes with this sometimes. You saw a few people on screen, but there are some awesome people that really make up this group, and all come in with that thought and process of, like, they're here to help benefit you teams, and to go that route. I think Cranberry Alarm's done a fantastic job with that. We hope you all agree with that as well, too. So make sure you do check out all the videos that have come out, all the different explainers, the prototyping processes all the way through. It's not just about the finalized product. It's the journey that gets there as well, too, and hopefully you can translate that with your team as you tackle the rebuild system. So, guys, congratulations on a great build. We'll be filming more of a full reveal video, like a typical one, in just a little bit. But that is going to wrap it up for Cranberry Alarm here in the rebuild season. We can't wait to see teams how you do as well, too, and make sure you check out on Fun Robotics Network all the other great stuff we have coming, as well as there may be an appearance or two by the Cranberry Alarm robot here. Do we have a name picked out for this robot, or is that TBD still?
TBD.
All right. So keep an eye out for that, and we can't wait to see how this competes, and hopefully even more so what inspiration your teams are able to take out for it. By the way, if you are inspired by Cranberry Alarm, let them know. Many of them are at different competitions. They'd love to hear about that. And of course, on the Chief Delphi thread and other areas you may find content. So thank you, everybody, for tuning in. We wish you the best in the rebuilt season, and we can't wait to see how you do. Thanks, everybody.
Goodbye. Good luck. Bye.
Great job, everybody.
Woo! It's a wrap. We're done. That's a wrap.
Thank you.
Guys, we did it. Go to sleep now.
Oh, but wait, we gotta film B-roll.
Wasn't that the B-roll?
Okay, so
We did get a
Already.
out with the freehand for sure, but
it's not his fault.
Yeah,
The
yeah.
gyro is off.
I got halfway in the ramp and the gyro
It
flipped
turned.
45 degrees.
It was like,
I got slow-mo of that one.
See you next
did it
week.
really?
Okay, so
Can you put it in Discord so I can
are you
see
in
it?
a new
Oh, I
stream or
do.
no?
I can see it.
Add me to the
I think he's going to end it right now.
Now that I
point.
have you.
Good point.
I will do that
Now that we've
immediately.
finished.
Doesn't say like. I know.
Are you not on the Discord?
I know.